Welcome! So today we're going to talk about chocolate. Everyone loves chocolate. I love chocolate, you love chocolate. It's delicious, it tastes so good. And that is because chocolate is made up of many different ingredients. But for today we're going to focus on one ingredient in chocolate and do a little math problem. But as a background, chocolate is made up of a lot of different ingredients such as cocoa. Some forms of chocolate have milk. We have lots of sugar, which is where it gets such a nice sweet flavor to it. Between the cocoa and the sugar, that definitely gets a lot of people. So today we are going to focus on one compound in chocolate. So one compound, theobromine, which is misleading because there is actually no bromine in this compound. So if you take a look at our molecule, we have carbon, hydrogen, nitrogen, and oxygen in it. And this molecule right here is closely related to the cocoa in chocolate. So that's what we're going to focus on today, is this one molecule that's C7, H8, N4, and O2. And this little structural formula right here, if you don't see 7 carbons, that is because there is one carbon right here, one carbon right here, one carbon right here, one carbon right here, one right here, one here, and the last one is up here. So at those spots where there are no elements written, those junctions, that is carbon right there. So let's do a little bit of stoichiometry today. So our goal is to eat 250 grams of theobromine. So if we're eating 250 grams of theobromine, that means that we're eating more grams of chocolate. So we're eating a lot of chocolate. We're eating more than 250 grams of chocolate. But I want to know how many moles of theobromine we'll be eating when we eat that much chocolate. So given to us is that we want 250 grams of theobromine. What else we can figure out about the theobromine, since we do know the chemical formula, is we can calculate the gram formula mass for the theobromine. And if we take a look at all of our elements in the compound, we can get started because we know that it's C7, so 7 times the 12 grams per mole, which is the gram formula mass for carbon. Next up we have our hydrogens, and we know that we have 8 hydrogen atoms in this molecule, so we can multiply 8 times 1 gram per mole, which is the gram formula mass for hydrogen. And we know that we have 4 nitrogens, so we can multiply 4 by the gram formula mass of nitrogen, 14 grams per mole. And then last but not least, we have our oxygen. We have 2 oxygen atoms in this compound. So we can multiply 2 by the gram formula mass for oxygen, which is 16 grams per mole. What we notice about all of our gram formula masses is that they all have the same unit to them, grams per mole. So that means that we can add them up together because they will have the same unit. So the gram formula mass, I'll give us a moment to calculate that for the whole molecule of theobromine. So we'll get 7 times 12 plus 8 plus 4 times 14 plus 32, which is 2 times 16. So that will give us about 180 grams per mole. So that is the gram formula mass for our theobromine, 180 grams per mole. Our next step will be to convert our mass, which we know to be 250 grams of theobromine, to moles. So we have here the given, which is 250 grams, and we will divide that by 1 because that will just equal itself, still 250 grams. What we do also know is the gram formula mass for this compound, which is 180 grams per mole. So we can take that conversion factor and multiply it by our given 250 grams. But in order to do that, I have to flip the fraction over. So instead of 180 grams divided by 1 mole, it will be 1 mole divided by 180 grams. Both of these fractions, the 1 over 180 and the 180 grams divided by 1 mole, are equal to 1, so we can flip them over and it will still divide in equal to 1. So our conversion factor can be flipped over. And what we see here is that we can cancel out some units. So I'll give you a moment to see which units we can cancel out. Good, we can cancel out our units of grams. So we'll have 250 grams times 1 mole divided by 180 grams. We have grams in the numerator, grams in the denominator. That means that we can cancel those out. So our final unit will be in moles. And I'll give you one more moment to complete this calculation now that we know our final unit. And I calculated about 1.4 moles of theobromine. So, just to recap, if we have a mass of a known compound, we will always be able to convert from that mass in grams to moles as long as we can calculate the gram formula mass. And if you have your periodic table or your reference table, you'll be able to calculate the gram formula mass for any compound and use that to convert all the way to moles. Alright, well, thanks for joining.